So hello guys, welcome back to another video. This is going to be the final lesson for mathematics, the law of sines and ambiguous cases, as well as the law of cosines. So with one more topic to cover before the final exam, let's finish this once and for all. So let's first take a look on what the law of sine is. Learning from proportion, it basically states that sine of A over A, so sine of angle A over side A is equal to sine of angle B over B, and so on. An alternate form can also be made here where A sine of A is equal to B sine of B. This is also an acceptable form as well, and either way is convenient because you will get the same answer no matter which way you choose. So I'm going to take you through the step-by-step process by teaching you about oblique triangles. So first and foremost, I'll show you one example over here. So our first example over here, we need to figure out first on which theorems we can use on the law of sine. So I'm gonna pull up these. Oh wait, sorry, that's not meant to happen. Instead, I'll pull out this one over here. Okay, so let's do process of elimination first. First and foremost, I'll just be straight and I'll be quick here, but the only ones we can use law of sines are the first two. So this is SAA, ASA, or SSA. We're going to encounter these two first, and then this one will be our ambiguous case. Then these two over here will need the law of cosines, and I'll explain that when we get there. I actually don't know how to use SSS, so I'm only going to be going over SAS. Okay, so let's start. Example 1. Solve for measure of angle A, and side C. So let me get my calculator real quick and show you guys. Alright, so I'm back. Sorry for the ad, but I've got my calculator now. So we're looking for measure of angle A, side A and C. So M, A, and C. First and foremost, let's easily knock off angle A. We know that this is a triangle, and we can use the property of a triangle that states that all three of these must add up to 180. So, knowing this, we know that 47.52 plus 62.43, let's put that in our calculator first. 47.452 plus 62.43, that's gonna be equal to 109.95. Then we do 180 minus 109.95, and that's going to be equal to the measure of angle A, which is 70.05 degrees. So let's mark that there. Right. Now we need to find for side A, and this is where we can apply the law of sines. So let's start with an existing value we have. We must have the side and the angle of it. So we do know that we have angle B and side B, so we can use that as a reference. So angle B is 47.52. So therefore, we can just put in sine 47.52 over 4.16. Now, if you're confused, the one at the top is just sine of angle B, which is this one. And what I put here, 4.16, is the side opposite to angle B, which is this one, 4.16. Similarly, to make our equation, we can do the same thing for angle A. We do know that angle A is sine of 70.05, but we do not know what the side length is. In order to find out the answer, let me just box this real quick. We need to cross multiply. So we have to do sine 70 0.05 multiplied by 4.16 all over sine 47.52. For more advanced calculators, you can actually just type this in and solve for x, but this is also a valid solution if you're required to show your solution. So let's type that in our calculators. Sine of 70.05 times 4.16 all over sine of 47.52, that's equal to about 5.30. So that's our side A. Now we can apply the same logic for side C. So the best thing to do is not to use any of your calculated sides and just refer to the given. Because of this is actually an approximation, and the actual value of this side is much closer to something like this. Although we only add the first two decimal points, so we just have this. So by omitting this long section over here, it causes some inaccuracy. So instead of using sine, the sides we solve for, we just copy paste this one for side C. So we have sine 47.52 over 4.16. Now instead of, we're looking for angle C, so let's see if we have something for C. We do have angle C, so that's sine 62.43 all over, we don't know. Let's apply the same method over here. Sine 62.43 is equal times 4.16 all over sine of 47.52. Let's put that in our calculators. Once again, repeating sine 62.43 times 4.16 all over sine 47.52. We get an approximate value of almost exactly just 5. And if you really need to know the decimal places, here you go. There we go. Okay. Good job. That's our first case over here. This is an example of AAS. Because we have, as you can see over here, we have a given angle, another given angle, and we have a side. So this is AAS. Let's now take a look at the next example over here. It's a little bit different. I'm just gonna go remove this so we can check it later. So this is going to be, now this is a little different. Well, not different at all actually. It's still AAS, but the angles are a bit more different, but the method's still the same. So once again, we're looking for measure of angle D as well as the sides of D and F. First and foremost, let's start with the obvious once again. We can use the properties of a triangle to find out angle D. So we do 122.2 plus 26.86. That's going to be equal to 149.06. Let's write that down. Then we just do 180 minus 149.06 to find our answer. That's going to be equal to 30.94. And that's our answer. Very nice. Alright, I hope you get the drill by now, but let's try it again. First and foremost, we need to find the pair of an angle and the side that's already given to us. So that's going to be this one, angle E, and the opposite of it is called side E. Nice. So we're going to use the formula again. So sine of 122.2 all over 7.84 is equal to, we're looking for angle side D, so we're doing sine of 30.94 because this is angle D over here. All over, we don't know. Applying the same step from last time, let's try that again. We get sine 30.94 times 7.84. Sorry, all over sine of 122.2. Plug that into our calculator, guys. So sine 30.94 times 7.84, is that correct? Yep. All over sine of 122.2. That leaves us with an approximate value of 4.76, and just to confirm your answer is exactly correct, I'll add in the other decimal places. So 4.76352101. Okay, very good. Oh, sorry, degrees. Make sure to add degrees, guys. All right, let's apply the same logic with side F. Once again, just like last time, do not use estimated values, just use the given. So let's copy paste the sine 122.2 7.84 to ensure maximum accuracy, and then we just give out the values that we need. So this time we're looking for this angle, so it's gonna this side, this one. So we just need to give out sine 26.86 over, we don't know. Perfect. We now can apply that once again to our calculator. Sine 26.86 times 7.84, sorry, is equal to sine 122.2. So we're going to put that in our calculator. Sine 26.86 times 7.84 all over sine 122.2. That'll give us an approximated value of 4.19. But you might be asking, if you did this correctly, you might be wondering, why do we have 4.186049092, and why didn't we do 4.18? It's because we need to look at this digit over here, the third decimal digit, and if it's 5 or above, we need to add 1 to this one. So since it's 6, we need to round up to this one, so it's going to be 4.19. And there we go. That's another case down. I hope you're getting the gist of it so far. This is actually, in my opinion, the harder one out. Oh, sorry. In my opinion, this is the harder one out of the two, actually. Because for law of cosines, you just need to substitute in the values, or just use law of sines to find the remaining values. Alright, let's continue. We're going to now go with the third example. Once again, hide this for later. Alright, now it's a little bit different. We have an angle, a side, and another angle. So that's going to be AS. Where did the thingy go? Here. So it's going to be ASA. This one's ASA. Oh, okay. This is an entire mess right now. Sorry. Anyway, first and foremost, we need to find a measure of angle J. We got side K and side L. Let's do this. So once again, let's apply the property of triangle. 59.77 plus 80.99 is equal to 140.76. I'm not gonna write that down because I think you get the gist of it. And by subtracting that, we get 39.24. Next, we need to find angle K. Now that we have a given over here, now we have an exact value over here, we can still use this as we computed for the angle the mathematical way, so it's exact. So we can now use this as an example. So we got sine of 39.24 over 3.05. That's our sine j over j is equal to, we got k, right? K. So sine of 59.77 all over, we don't know. Once again, let's reapply that cross multiplication. Sine 59.77 times 3.05. All over sine of 39.24. Let's put that in the calculator once more. Sine of 59.77 times 3.05 under sine 39.24, that's equal to 4.17 approximately. And then we just need to add, I'll just give you some more context of the exact answer. There. But the red box is the one you answer on the test. Next one, side L. As per usual, copy paste the given that we used for the last equation. Then just change the second side. So we now are looking for L. So L is 80.09. So we just 80.99, sorry. Sine of 80.99 all over x. That can be translated into sine of 80.99 times 3.05, sorry. All over sine of 39.24. So sine 80.99 times 3.05 all over sine of 39.24. That will give you an approximated value of 4.76. And then here's the other decimal places for you guys. Very good. We have solved. Very good. We have solved all of the three problems were given us, and this is a fairly easy one. The next one for me is the hardest. If I were to rate this, it would be law of sines, law of cosines, and that the hardest is the ambiguous cases. It's pretty tricky. So I'll show you that in a bit. Alright, so this is a pretty tricky one, and there's literally 6 cases to memorize, so yikes. So first and foremost, we're just gonna take a quick look at this one, and you can check it out first. We're gonna try to illustrate this as many cases as we can. Okay, I think we have an example for some of these. Okay, yep, makes sense. Alright, so we're gonna illustrate this triangle. Solve a triangle ABC if angle A is equal to 55 degrees, A is equal to 23, and B is equals to 25. So first, let's draw the 55 degree angle. So this is clearly going to be a acute triangle. So it's going to be like this. So it's going to be 55 degrees over here. So that's going to be angle A. But we also do know that A is equal to 23. So this is side A. And B is equal to 25. So this is side B, 25. So we need to solve for if there's many more cases. If there's what do you call this? If there's two or more possible triangles that we can form with these given measurements. So this is actually going to be something like this, and I'll show you later. Alright, so first and foremost, we can use the law of sines to begin with here. First and foremost, let's find out what this one is. So, let's do sine 55 over 23 is equal to sine, we don't know, and 25. So this is going to be a little interesting here. So we're going to do the same thing again. We have sine 55 times 25 over 23. So let's put that into our calculator there. Sine 55 times 25 all over 23. Now, you might be surprised, why do we get such a small number? We get 0.890. The thing is, we need to multiply this, whatever estimation. Do not type in this in the calculator. Just after solving this, you want to click the answer key times sine raised to negative 1 answer, which is just this one. So we're gonna do sine raised to negative 1 answer. And then you actually get a reasonable answer of 62.92. So angle B is equal to 62.92. Now, what can we do from here? Well, first and foremost, we can solve for side C. We can solve for angle C, which is just an approximate value. So 62.92 plus 55, and then 180 minus that is equal to 62.08. It's your C. Now, what we can do is actually modify this triangle to make it an oblique, and I'll show you that in a little bit. Okay, first and foremost, to make things easier, let's round off these numbers. This will become 62, and this will become 63. I'm pretty sure we can do the same in, this is what the instructions told me, so I'll go by that. First and foremost, we can obviously solve this as our first answer. 62 is over there. But how do we get the second answer then? Well, first and foremost, we get, is equal to, okay, so first and foremost, we did 180 minus 63 minus 55. And that is 62. And let's prove that by using law of cosines. Sine, sorry. So sine 55 sine 55 over 23 times sine of sine of 62. Okay, we haven't solved for this, so we can't really solve. But this is 62 by subtraction. Can we use that? Yeah, no, it's fine. So we have C1 is equal to 62 degrees by subtraction. But another thing that you can do is find the complement of this one, this angle B. So your angle A remains constant. So we can do 180 minus the complement of this one, which is just 180 minus 63. That's equal to 117 minus 55. These are the constants. Then you just need to find the other angle of this one for a supplement. So therefore, it's still, after solving this, it's equal to 8 degrees. 180 minus 117 minus 55 is equal to 8 degrees. And that's our ambiguous case. So we can either have this triangle over here, or, can I illustrate that? don't know how to illustrate that. Okay. Or this angle over here. So these are both abiding by the rules. So this is 25 and this is 23. So yeah, these are both valid triangles, and this is a case where we have this. So let's try to prove our statement over here. We can't really find the hypotenuse, unfortunately. That's quite unfortunate. So yeah, I don't think we can prove that, but this is the correct answer over here. We just have to find the supplement of this angle B, and then we can just solve by subtraction to find the other one, C. So yeah, that's the answer over there. This is going to be your angles, and that's going to be an example of 2 possible triangles. Meanwhile, let's try to do that on the third angle here. Let's try to do this one here. Solve for... Okay, let's try to draw this again. So once again, we have a triangle with a 44 degree, and A is equal to 11, while C is equal to 7. We don't know what B is, unfortunately. So let's use the law of sines once more. So we do sine 44 over 11 is equal to sine we don't know over 7. Plug in that to your calculator. That'll become sine 44 times 7 over 11. Sine 44 times 7 all over 11. That's approximately equal to 0.442. Then just keep that answer. Sine -1 answer, which is this one. That's going to be equal to 26.23509277, or just 26.24. Now, since we're now dealing with multiple decimal places, I think it's okay that we use these for now. I don't think... Okay, so we're just gonna use this for now. So let me just double check. Okay, so actually I'll just repeat this right now. For all of the ambiguous cases, it looks like I've seen a pattern over here that we just take the whole number or round up or round down. So it's really just 26 for simplicity's sake. So 26 is our angle C. Now we have a slight now obviously we can find angle B, right? We do 180 minus 26 minus 44. So we do 180 minus 26 minus 44. And that's obviously equal to 110, right? However, what if we try to find the second triangle over here? Let's find the complement first of 26. That's 180 minus 26. That's 154. 180. All right, let's try this. 180 minus 154 minus 44. Oh, you get a negative 18. And this is one of the rare cases where there's only one triangle, because since we're subtracting from these two angles, 154 plus 44, since that's greater than 180, this is the only possible triangle we can have. So in this case, there's only one triangle formed, and it's when this one is equal to 110 degrees. So there's two triangles over here and one triangle over there. And that's how we illustrate the ambiguous case of law of sines. Oops. Just do a little bit of a memorization here. And yeah, there we go. We are, well, kind of almost done, I guess. We just need to do law of cosines. Okay, so now let's try to not get overwhelmed now, because this is the law of cosines. Honestly, once you just remember one specific letter here, like for a squared and angle A, you kind of know all of it. So let's try to use all of this. So this is for a side. Oh, let me just label this. This one's for side, and this one's for angle. So I'm gonna try to, I don't know, solve this. I'm gonna try to show you how to solve this. So first and foremost, we need to solve for side A. So the letters don't really matter here, but let's go for side A anyway. So first and foremost, side A squared is equal to B squared. So side B squared, we want to first type in parentheses, 12.9 squared. So I'm going to go slow here. So 12.9 raised to 2. Very good. Then we do plus C squared. So we need to find C, that's 15.4, plus 15.4 squared. So type that in your calculator. Plus 15.4 squared minus 2. So just put minus 2 there. And then in parentheses, BC. So we got BC 12.9 and 15.4. That's what you type in your calculator so far. Lastly, we're going to find cosine A, which is given. So that's just 42. Cosine 42. And you just need to type that in your calculator and you have side A already. Well, not really. That's A squared. So I'm going to type that in over there. Oh, what happened here? Sorry about that. I got into an error, but let's just try to type that once again. Minus 2, 12.9 times 15.4 times cosine of 42. And after solving that, we get that A squared is approximately 1083036,979. We don't round off here. Just keep your answer. So square root your answer in the calculator, where we get A is approximately 10.040690626, or just rounded off to 10.41. And that's your answer. Alright, let's try to solve now for the others. This one is pretty tricky. In other calculators, they do not accept this, so we need to go a little bit slower here. So first and foremost, we have to do, let's try to solve for angle B first. So measure of angle B is this. So we now know that A squared is give or take 10.41. So we do in our calculator first 10.41 squared plus C squared, so that's 15.4 squared, plus minus B squared. B squared is 12.9 squared. Let's just do that over here. Let's type all of that in. 10.41 squared plus 15.4 squared minus 12.9. Nope. 12.9 squared. That's going to be equal to 179.1181. And that's all over 2AC. So 10.41 and C. So that's going to be 10.41 and 15.4. Let's plug that into our calculator. 179.1181 all over 2 10.41 15.4, and you get a answer of approximately 0.558 ... and then you just do cosine -1 answer to get the it's the angle. Yeah, it's the angle, my bad. Anyway, that's the angle, so we just do cosine -1 answer, which is this one, and you should get about 56.0376 ... which is equal to B is approximately 56.04. So I'm gonna take a short break. I've been through quite a lot today, but I hope you're starting to get the law of cosines. Alright, so this is correct for angle B. I just had dinner. I apologize for that. I was really hungry, so yeah. Anyway, let's now... Oh, I did not label the solutions. Okay, there we go. So time for angle C over here. We're gonna just do the same process again, but just slightly different. So we have a angle C over here. So we're just gonna do the same formula, okay? I'm gonna type in almost the same formula. That's gonna be angle C is equal to first A squared plus B squared minus C squared. Okay, perfect, easy. So we got 10.41 raised to the power of 2 plus 12.9 raised to power of 2 minus 15.4 raised to power of 2. All right, let's turn that into an actual numerical value. We're gonna have 10.41 raised to 2 minus plus 12.9 raised to 2 minus 15.4 raised to 2, and we get about... that is correct, right? Okay, we'll see. That is correct. That will lead us to having 37.6181. Now we're just gonna do 2AB. So that's 2 10.41 and 12.9. Let's separate these by a line over here. There we go. Okay, so now we just do this, plug it into our calculator. So we got that one answer all over 2 10.41 times 12.9. So yeah, we do get about 0.140063965, and then we just do that cosine -1 answer, which was just this one. So we're going to do cosine -1 answer, and that's equal to 81.95. Is that correct? Okay, so let's see. 81.95 degrees. Oh, I can't mark it for some reason. Now let's try to add up everything here. So we got 81.95 plus 56.04 plus 42, and we have an unfortunate incident that it's all equal to 179.99 if we add these three angles up, this one, and that one. So what you just need to do is just modify the last angle here. So we turn it into 81.96, and that's our final answer. All right. Now, our next thing we can do is, we've already covered all of this. So we did SAA or ASA on the first part. We did the ambiguous case of SSA, and the actual last problem we solved was SAS. So all we need to do to finally finish this, and well, other than the applications, is the SSS. Now perfect, we only need to use one formula over here. And although you can just use one formula and then use law of sines to solve the rest, it will result in a margin of error, so it's better to be playing it safe and use this one instead. So I've already told you how to notate it, so I'm just going to substitute all the values over here. If your calculator can handle fractions like this one, like typing something like this into it, good. If not, just once again solve for this one first. Oh, what did I do over there? So solve for this one first, and then find this, write that down, then solve for this one, and then you just cosine -1 that answer, okay? So there's always a solution for everyone, and make sure you get, just the best calculator you can. So let's start first for solving angle A, which is the cosine -1 is equal to b squared plus c squared. Is that correct? B squared plus c squared minus a squared all over, oh, okay, there's some liquid there. Some liquid that's messing up my screen. 2bc. So, yep, we're going to use that, and let's substitute all values. Cosine -1 all over b squared, that's 25 squared plus c squared 12 squared minus 18 squared all over, is that correct? All over 2 times 25 plus 12. Let's do this. Let's put that into our calculator. Oh, don't forget the cosine -1 though. Shift cosine -1. Let's make a fraction. 25 squared plus 12 squared minus 18, squared, all over 2. Oh, sorry. 2, that's a times. I'm so sorry. 2 times 25 times 12. I'm so sorry, guys. 2 times 25 times 12. And then we just calculate that, and that's equal to this one. M angle A is approximately equal to 42.13. So let's try measure of angle B. It's almost the same thing. Cosine -1 a squared plus c squared minus b squared all over 2ac. Is that correct? Correct. And then we're just going to substitute once more. Cosine -1 and then we're just going to do this again. That's equal to a squared, which is 18 squared, and then b squared, c squared is 12 squared minus 25 squared. Now, if you plug this in manually, it's okay to get a negative number. It's normal for cosines, but not okay for sines. And then we just do 2 times 18 times 12 at the bottom. Plug it into the calculator. We get cosine -1 square, in parentheses, 18 squared plus 12 squared. Okay, what am I doing? Plus 12 squared plus, minus 25 squared. Underneath it is 2 times 18 times 12. We're gonna close the parentheses over there. Let's equal that. And that's equal to b equaling about 111.31 degrees. Lastly, for measure of angle C, it's just going to be the same thing. Cosine of -1, but this time it's going to be a squared plus b squared minus c squared all over 2ab. Substitute that, we get cosine of -1 is equal to a squared, that's 18 squared, plus 25 squared, minus c squared, 12 squared, all over 2 times 18 times 25. Let's put that in. So we got cosine -1. Over here we got 18 squared. Ooh, I'm running low on battery. 25 squared minus 12 squared, all over 2 times 18 times 25. And then we're just going to close that parentheses. And then we get an approximate angle measure of measure of C is equal to 26.56. And then let's just add them all up to make sure they're all 180. So 42.13 plus 111.31 plus 26.56. That is equal to 180. So let's just verify if our answers is correct. And very good indeed. That is all our correct answers. Very nice if you got those answers too. I hope you're able to understand. So yes, we have illustrated the law of cosines, and now it's just time to apply this in real life. Okay, I'm really tired. It's been a really long day, but let's just do one more final push, shall we? Alright, so this is going to be our last topic. This is going to be the application of, or the problems relating to the oblique triangles. So this can be either law of sines or cosines. Okay, yeah, let's just finish this. Oh, what did I do? Okay. So, sorry. So we have our first one. Problem 3. A tree leans 7 degrees and the angle of elevation from a point of the ground is 12 meters away from the base of the tree is 33 degrees. How far is the point from, how far is the point on the ground to the highest point of the tree? First and foremost, let's say we have a tree. Okay, what did I do? Okay, here we go. First and foremost, let's say we have a tree over here. But we do know that it leans 7 degrees, so it's something like this. Oh. You know what, I'll just add a new layer. So once again, we have a tree, but we know it leans 7 degrees. So let's just make it really steep. There we go, 7 degrees right there. So let's just add like an imaginary, just keep the imaginary line. There we go. So we'll call that 7 degrees. Meanwhile, we know that this one, the base, is 12 meters away from the person viewing it, or the point in the ground. 12 meters. And then we also know that the angle of elevation from this person is 33 degrees. With that in mind, let's try to find the law of, let's try to apply the law of sines in order to solve this. So first and foremost, the first thing we can do is find out this angle over here. That's going to be your that's gonna be 90 because this is a right angle. So 90 minus 7, that's just 83. And then by property of triangles, we can do 83 plus 33, which is equal to 116. Then 180 minus that is equal to 64. Is that correct? Okay, yeah, that is correct. So, for now, I want you to observe for a bit, and let's see how do you think we can solve this. Although it's quite hard to see, we do have a 64 degree here, and it does hit this 12 meters here. So since we have a side and an angle, we can use we have a side and its opposite. We have an angle and its opposite side. We can use the law of sines. Therefore, sine 64 is equal to over 12 is equal to, we're looking for the point on the ground to the highest point of the three, this one. So we're looking for this side, which means we need to use sine 83 to find it out. Sine 83 is equal to nothing. All right. Cross multiplication. Sine 83 times 12 all over sine 64. And let's put it in our calculator. Sine 83 times 12 all over sine of 64. Nice. And that's approximately 13.25 meters. Good. We've now used this is the law of sines in a real life application. Last problem for tonight. And yeah, thank you so much for supporting me, really. So yeah, I'm having a little bit of trying to get myself together. But yeah, let's do this. So, two ships are sailing from Palawan. So let's call this Palawan first. Let's mark Palawan here. And then after 1 hour, we know that ship A. Okay, let's see. Ship A is sailing due east, so it's going here. And after an hour, it has traveled 87 kilometers. Meanwhile, ship B is sailing 44 degrees north of east. So 44 degrees like this. So that's 44 degrees over here. And we do know that ship B has traveled 146 kilometers. So we can add like this. 146 kilometers. Now this is the ship 1 over here, the ship 2 over here. Then we have C. So this is A. And this one is B. And we do know we want to figure out how far are they. So we're finding this red line over here. We have a side, an angle, and a side. Sorry. This is SAS, which means we need to use the law of cosines. Since we're looking for a side, we have to use the c squared, which is, to recall, c squared is equal to a squared plus b squared minus c squared, no, minus 2ac cosine c. AB. This one. Yeah. Okay, so we have, we have c squared equals a squared plus b squared, minus, minus 2ab cosine c. So let's put that into our calculator. So we don't know c squared, but we do know that a squared is 87 squared plus b squared 146. No, a squared, sorry. A squared is technically this one, so it's 146. 146 squared plus b squared, so that's 87 squared, minus 146 times 87 times cosine, are we given? 44. Let's plug that really long equation into our calculator. 146 squared plus 87 squared minus 146 times 87 times cosine 44 double parentheses. That's it. We'll have our answer over there. C squared is equal to 10,610.89171. C is equal to 103.0091827. C is approximately 103.01 kilometers, and that is our answer. All right. congratulations. If you made it this far, you have completed and you're now fully ready for the final math assessment. So, if I sound a little tired, and yeah, I've gone through a lot today, but I just still wanted to help you guys. So yeah, once again, make sure to take care of yourselves. Especially we're nearing the end of the school year. Make sure to take care of yourselves. Get a good amount of sleep, and yeah, I'll try to do the same as well. So once again, thank you so much for watching, and I'll see you in the next one at Study Guides. Bye bye.